In this problem, we are given a four-state transition diagram. We know that it represents a Moore machine because the output is a function of only the current state. We are also given a partially filled out truth table, and our first job is to fill in the missing entries in the truth table. In order to do this, we need to find the correlation between states A through D and their S1, S0 encoding. We begin by looking at the output column. We know that only state A has an output of 1, so state A's encoding must be 0, 0, and out equals 1 regardless of the input because it is a Moore machine. We also know that from state A on a 1 input, the FSM moves to state B. According to the truth table, from state 0, 0, which is A, on a 1 input, we move to state 0, 1. That means that state B's encoding is 0, 1. We continue in this manner, now following the transitions from state B. According to the diagram, when n equals 0, we move to state D. So looking up that transition in our truth table tells us that state D's encoding is 1, 0. We also see in our state diagram that starting at state B, when n equals 1, we move back to state A, which we now know to be 0, 0. So we can fill in the next missing entry in our truth table. Now that we have determined the encoding for states A, B, and D, we know that the remaining encoding is for state C, and that is 1, 1. At this point, we have all the information we need to complete filling out the missing entries in the truth table. Looking at the row where the current state is 1, 0, state D, and n equals 1, and the corresponding transition in the state diagram shows us that in this case we go back to state D. Since the encoding of state D is 1, 0, the S0 prime entry is 0. Because it is a Moore machine, we also know that the output associated with current state D, regardless of the input, is 0, so the missing output entry is 0. Finally, from state 1, 1, which is state C, when n equals 1, we see from the state diagram that we transition to state A, which is state 0, 0. So the remaining missing S0 prime value is 0. We now want to determine whether or not there are any equivalent states in this FSM. In a Moore machine, equivalent states have the same output and the same input transition. This rules out state A because it is the only one that has a 1 output. Taking a closer look at states B, C, and D, we can see that both states B and C transition to state D on a 0 input and to state A on a 1 input. In addition, the output value is 0 for both of them. This means that states B and C are equivalent and can be merged into one to turn this into a 3-state FSM.